When we submit the job to the job tracker is going to communicate with the name node. For what sake it is going to communicate with the name node? Because we know very well that when you are giving when you are submitting the job to the job tracker, what is that we are doing? Hadoop jar, you are saying Hadoop jar, specifying where the jar file is located, maybe slash home slash Srinivas slash work slash MapRed, and I'll be having something called mrjobs.jar. This is a path where the jar file is located. And in this jar file, there could be number of jobs. That is the reason why we are specifying. Why we are specifying that, this is a job that needs to be run. Word count. And this is the name of the job. When the job needs to run, the purpose of the job is to process the data from where the job needs to read the data, that needs to be specified. That is called the input path. This is on your HDFS /tmp /sandbox, and we are going to specify /tmp /sandbox /Mary.
Srinivas?
Yes.
Sorry, sorry for interrupting you. I have one quick question.
Yeah, please.
Earlier, you have run a MapReduce job on Mary, right?
Exactly.
Yeah, but we have run that as Hadoop jar, and we have given the jar location as user/lib/something.
That
But the
jar file
data,
could be anywhere. That is the reason why intentionally I am showing you here. Home, Srinivas, work, MapRed, mrjobs.jar, or it could be any path. But this is the path where your jar file is located. This
so
can
even
be,
I can, like, in the workspace?
yeah, this can be anywhere on the local file system.
On the local file system, okay.
On the local file system, exactly.
Okay, whatever you have run earlier in the program, right, for Mary, so
Yeah,
where can I find that particular jar?
I'll show you now.
Oh, I see. Because I was trying to run it, so it was showing me there is no such kind of jar. So I was like a bit confused.
I'll show you now.
Okay.
/tmp /sandbox /Mary _out. So whatever we are giving here, this must exist. Whatever we are specifying here, this must not exist. Because this directory will be created during execution, during runtime, the directory is created. During runtime, the directory is created. So you look closely into this entire thing, you understand. Hadoop jar, specify the path where the jar file is located, and in that, what is the job you want to run. And when the job is running, from where it needs to read the input. When the job is going to process the data from the input path, it produces some output where the output needs to be stored. So everything is clear here. This is all very systematic. This is all very systematic. There is no need for you to by heart even. Hadoop jar, that is the only thing we need to know. What jar file needs to be executed, where that jar file is located, that path. In that jar file, there could be number of jobs, which job needs to be executed, we are specifying. When the job is running, what is the purpose to process data? Where to get the data, input data, we are specifying. When the job is going to finish, it produces output. Where it needs to be stored, that also we are specifying. So when all these things are being specified, then you look at this one closely here. Your job as a client, we are submitting the job. We are submitting the job to the job tracker. What the job tracker will immediately do is, it communicates with the name node. Why it communicates with the name node? It communicates with the name node for the reason, this input path, whatever is been specified, this input path could be, observe very closely friends, could be a file or directory or a glob. What do you mean by this? What do you mean by this? That could be a file. Well, we understand. Mary, we have already given. Directory, that also we can fairly understand. Glob means we can specify an expression with wildcard characters. Matching with that regular expression, what all the files that are allowed, all those files will be processed. That is what I mean by glob. Matching with that criteria, what all the files that are allowed, all those files will be processed. Hope this is clear to you. So, when the job tracker receives the job, the reason why it communicates with the name node is to understand for this given path, input path, where the blocks are going to exist. The name node is going to reply saying, for this input path, there are 100 blocks and those blocks are present on node 1, node 3, node 4, node 9, node 11. Assume, this is only the assumption. 100 blocks are there, those 100 blocks are present on these nodes, like this, maybe more nodes. That response is going to be given by the name node to the job tracker. Then immediately what the job tracker will do, whatever the jar file that we have submitted or we have sent to the job tracker along with the request that you made as a client, this job tracker will push this .jar file to node 1. Same jar file will be pushed to node 3. Same .jar file. And same .jar file will be pushed to node 4 even. Hope you are getting the point what I am sharing here. So what will be there on the nodes? Task tracker will be there. On each node there will be task tracker. On each node there will be task tracker. What task tracker will be doing? What the task tracker will be doing? The task tracker is going to receive that jar file, and that jar file will be executed locally here. Now this is one JVM to process one block. One more JVM to process one more block. One more JVM in the same, maybe to process the third block. If resources are available, it keep on spanning the JVMs to process each block. Same point of time on this node also. So within the node, you have a parallelism, and across the nodes also there is a parallelism. This is what we call it to be massive parallel processing. It is not processing the data sequentially. It is processing the data parallelly. And not just parallelly, massive parallel it is processing. That is what the beauty part of your MapReduce. If you are able to understand this one, most of the complex things you can easily understand, friends. Massive parallelism. What is the theme of the massive parallelism? If you understand, you can easily understand many other things. Now, going back to this, is this clear to you, friends? Is this clear?
Just have a question, Ram.
Yeah, Ram, tell me.
You're saying like on each node we have like different blocks that will be processed parallelly using multiple JVMs. So is that each JVM is spawned into a different daemon? Is that the concept of daemon? I'm trying to understand the daemon concept.
Yeah, it will not a daemon. I mean, in that context, I can say it is daemon only because that is been you are not initiating that where you are interacting with that one. So it is no doubt a process running in the background which you will not be able to see. In the user perspective, it is a daemon only. User perspective, it is daemon only.
You mean each JVM is that is getting created to process the different pieces of code parallelly. You call that as a daemon, and like what exactly is a daemon?
So daemon again, if you see your name node, your secondary name node, all those things also comes under daemons only. But those are the process running in the background forever till. But these are, I cannot call these to be daemons for the reason these are going to live only for a specific amount of time. And after that, say for example, here you see, I cannot call them as daemons only for the reason I call these as process basically, not the daemons. Because this JVM starts and it executes till what time? Till the block is been processed. Once the block is been processed, then that JVM is going to shut down. Of course, there is an option called JVM reuse. JVM reuse. So in the MapReduce, we can reuse the JVMs because JVM startup is an expensive process. So rather than we starting JVMs again and again, once a particular JVM process a block, it is over, then the same JVM is going to be used to process another block, so that we can avoid that JVM startup time, so that the job execution time is being reduced, and thereby the efficiency of the job increases. So these are called as process. Who is going to take care of initiating this process? Your task tracker. Your task tracker takes care of executing this process. So as a result, these comes into picture till the process the blocks. Once that is over, is done. So this is all I'm talking in the context of the map phase. It's only the map phase. We are not discussing anything about the reduce phase. This is the first phase. Once this is over, and all the blocks, I mean 100 blocks what I mentioned here, are being processed by the maps, then the reduce phase will come into picture. Till then the reduce phase will not come into picture. Only after the successful completion of the map phase. Yeah, Ram, tell me now.
Yeah, I got it. Like I got it. I was confused with the daemon, with the each JVM that you said. I thought it's a daemon, but as you say, it's a process.
Yeah, because these are processed for the reason they are going to work under the control of your task tracker. Then we cannot call them as daemons. Daemons are the background process that runs forever till from the startup till the end. We call them as daemons. Your name node starts. Your name node starts and is going to run forever, right? Same like.
You know, I have a question.
Please, please.
So in our example, the word count example, where we can see this job tracker and the name node configuration and all.
I didn't get you. Come out again.
So in our example, so we are just running the Hadoop jar and whatever the jar file specified path and the input file and the output for format. So where we can see this job tracker and how it is configured to the name node and all this configuration.
So
whatever you explain now.
Where you can see the job tracker and all you're asking.
Yes.
You will not be able to see, but you can feel that one. How is with your, say I go to my Hue browser, I have the access to my I have something called manage jobs. Here I'll be able to see. I'll be seeing the job under execution once been submitted by me. You'll be seeing the job under execution. That is only
Okay. So you're saying that is, so whatever you explain the process, that is internally to do like Hadoop. So there's nothing we can manage.
No, we can manage, but it's all programmatically. We can manage, but it's all programmatically. Not like when the job is been submitted, we go and do something. That we may not be able to do it. I'll show you now more in detail. The reason why I'm concentrating so heavy on this one is that important. That is the reason why we are discussing again and again the same thing, because not only here, everywhere, wherever you go across your entire ecosystem, you have your MapReduce in the background. So you need to understand how much important this is. You start working with your pig. There also you come across your MapReduce everywhere. So that is the reason
Yeah, I know this is
why
very
I
important
want
stuff.
you to clearly understand. Maybe you think you are writing a pig script and you are running it, but in the background it is actually a MapReduce job. So we need to have a clear understanding of the MapReduce. Then only it makes sense for you to actually work with any of the component across your ecosystem, not only in this. It's almost done. Of course, if required, we can write a MapReduce job to take care of all these, changing all these things and all. So I save this one here. You know very well how you copy this one from this place to your
Yep.
Hadoop EFS-ls /tmp. Inside TMP, what do we have? Hadoop EFS-mkdir/tmp/sandbox. I'm trying to create a directory there, and into that directory, Hadoop EFS-copy from local, that is Mary, to my TMP sandbox. And now here, mkdir mapred. So I only create this one to have a clarity that yes, all my MapReduce is related, I keep it here, but nowhere related to my example ZAR file. Hadoop ZAR /user/lib/Hadoop here Hadoop examples.zar. Are you able to see this one? You understand the path what is being mentioned here?
Yep.
I think Kirti, someone asked to raise this one. Where we find this file? Are able to look into this path? I mean, I couldn't see the name exactly. That's fine. She asked actually, right? What is the path to
Yeah,
find?
Srinivas. I'm just looking into it.
Yeah, please. So here you have your examples there, and in that I would like to run my word count, and the input path is /tmp /sandbox/Mary /tmp/sandbox/Mary_out. If I give this one, have a look at this. Connecting to resource manager. Of course, we are working with a yarn based cluster where you will have a resource manager, not your job tracker. So I explain you that one a bit later, but imagine that this has been submitted to the job tracker. But here it is actually been submitted to resource manager. Resource manager is the new entry in the place of your job tracker to do the same thing, but in a more enriched manner. What is that and all we see? Earlier there was nothing here, now you are seeing one, and you could see here very clearly each job that is been submitted to the job tracker will get an ID. This is unique. This is unique.
I have a question here, maybe too advanced. So the whatever the Java file we are running is like we are manually running now. We want to do it like a automated, like a scheduled one.
You are absolutely right. You are absolutely right.
How we can configure that scheduled? Like
we have something called Uzi. We have something called Uzi, with which you are going to with which we are going to set that one.
okay.
We have something called Uzi. You are using that Uzi. We are going to actually schedule the job. I mean, not just triggering it. If you want to schedule it exactly 5 o'clock in the morning, that also can be done. You want a job to get executed exactly 5 o'clock in the morning, that also can be done.
Okay. So that Uzi is a kind of resource manager for Hadoop.
No, not resource manager. He is a workflow execution engine.
Oh, okay. Workflow. Okay.
Yeah, workflow execution engine it is. Now you see the job that is been submitted to the job tracker. You have the task, you have a map task. The output of the map task is written to a part-m file temporarily, not permanently. This is a map task. Underscore m and underscore r. And here we can go to the level where we can see this attempt ID, finish time, job ID, because this task is a part of this job. Output size, progress, task ID, what is a map task type, whether it is a map or a combiner or a reducer, all those things you see here. You also has got logs here to understand. If anything goes wrong during your execution, you also can see very clearly here. So all in the context of your job. I think you noticed here. At the job level what we have, at the task level what we have, any counters are there, all these are the counters. The default counters for most MapReduce jobs. If required, these counters can be customized. These are built-in counters. We can have our own counters, custom counters. We'll talk about that one. So ultimately, you go and see what the output you got, that is to your /tmp /sandbox Mary underscore out is a directory created. You see here, Mary underscore out, the directory created. So there if you go and see you have a part.r file, it is going to give you the output saying and 1 time, love 2 times, Mary 8 times with capital. You also see that Mary with a small also exists. So if I refine my document, text document, and convert all my capital into small, then probably I'll get a more a closer number, because here Mary with capital M and Mary with small m are treated to be different. That is the reason why you got the output like this. So this is how you got the word count. So you may ask me one thing, Srinivas, what is the advantage of this word count program and why we need to start our learning process with this? There is a great reason behind this. I mean, this is all you will not find in the documents, or you surf the net, you will not find this kind of use case anywhere. This is only to make you to understand. Imagine, friends, how this word count is going to be helpful at a larger scale. Don't neglect that this is a word count program, initial program only to count the words and all. How this can be used at a large scale, have a look at this use case. The use case that I am trying to build now, have a close look at that one. There is a research scholar. There is a research scholar. This research scholar is doing the research in literature, especially English language, and especially on the writings of world famous authors. And the aim of this research is impact or influence of contemporary situations. I can say here contemporary social situations on others. Hope you understand what I am trying to share with you here. Impact or influence of contemporary social situations on the others. I mean, say someone lived between 1820 to 1860. There are some social circumstances, assume. Globally, church is ruling, and anything against the church has been severely punished, something like that. That is social circumstances prevailing that time. Somewhere between, I'm not sure, but I'm just telling you, somewhere 1900 to 1930, World War might be. I'm not sure when the World War happened, but World War. The impact of the World War on the authors lived between 1900 and 1930. This is what the goal or the theme of this research, so that once I study the impact or the influence of the contemporary situations on the authors from 1700 till 2016, assume. If I am able to do this research, I can easily predict what's going to be the impact of the social circumstances on the authors in the future. I am able to predict. I am able to predict that. Are you getting my point, friends, here? I can predict easily that yes, in the coming days, the impact may be this much percentage, or there will not be impact at all. The authors are doing their writings, not bothering about the social circumstances. We can make some conclusion. That is possible only when you do your data mining. And for that sake, what we do, have a look at this. As been mentioned by me here, 1700 till 2016, I classify like this: 1700 to 1750, I identify the famous authors. I list them. Same like 1750 to 1800. And 1850 to 1900, like this. I list all the famous authors and all their writings. I collect all their writings. I collect. Say here, I got five famous authors lived between 1700 and 1750. All their five authors' writings I collected, and I kept somewhere here. Home, Srinivas, my research. Under this, I kept 1700 underscore 50. Okay, is a directory, and in this I kept all the text files. Are you getting my point, friends? Please respond, friends. Then I will be able to understand. Oh, you are following with me. Otherwise, there is no point me giving this use case.
Not really, Srinivasan.
Okay,
So
let me
I'm not
finish
able
in the next
to.
few minutes. Then you are not still clear. Then I'll go through the entire use case once again.
Yep.
So under the same, we have again 1750 underscore 00, or maybe I write like this 1800, nothing wrong, and 1800 to 1850. All these are the directories, and I keep all my text files here. Belong to the authors of that particular time. All these are the writings. All these are the writings, nothing but your .txt kind of files. Writings of the authors who lived between 1700 and 1750, 1750 and 1800. So all these are the writings, I mean the plain text files I collected in that form and kept in this kind of directories under my research directory. Now what I do is, I run my same word count. I run my word count giving the input path as /home /Srinivas /my research, and in that 1700 to 1750 is what I give, and the output path is 1700 underscore 1750 underscore out. Easy. This is the input path and this is my output path. So after processing is been done, it is going to keep the data there. Okay. So after the output comes, I have my own BI mechanism kept in place. With that BI infrastructure, I have the possibility to take out all the words like a, and, is, was, all these kind of words will be taken out from that list. I mean, what the output you got here, like you see this one, it, in, and you see here and, a. So all these kind of words, okay, I'll be taking out, I'll be removing all those things. To, and like this, all these are going to be removed by me from the output what I got. Are you getting the point? So that these kind of verbs and all, which are not required to be used as part of the analysis, that I eliminate. So what will be left over? The leftover is going to be the words that have been actually used by the authors as part of the writings. Out of which, using my BI infrastructure, I'll identify top 20 words used by the, now we have that one, right? We keep this in the order. You see this output, this is 13 times, and this is 5 times, and this is 4 times. If I sort them based on their appearance or based on their occurrence, then I will easily get what are the top 20 words being used by these authors who lived between 1700 and 1750. So top 10 words I will, or 20 words I'll take. I keep one side. I come to know the social circumstances that time. Maybe some war was going on that time, or some major health problems prevailing that time, maybe a disease, a plague kind of disease is getting spread during that time, something of that sort. So that I take into consideration, and I see what percentage of these social circumstances impacted the author to use some words related to that one, to that context. I come to know out of 20 top words or whatever, you take 30 or 40, that all depends upon the actual needs of the researcher. You may take top 20 or top 200, whatever. In that top, but I use the same parameter for every context. So top 200 words I take. Out of top 200 words, the social circumstances prevailing that time, from that context, how many words are there here I can see. Say 25 words or 50 words, maybe around 10% here, and here it is 20%. So the impact of the social circumstances on the writings of the authors is around 20%, like that I identify. Between 1700 and 1750, 1700 and 1750, this is impact. Same I calculate 1750 to 1800, this impact has gone to 25%. And 1800 to 1850, this has gone to more percent, 28%. Like that I get all the inputs. I got the graph, and the graph I got is something like this. Okay, assume that this is the graph I got. When I get a graph something like this till 2016, now by analyzing this graph closely, can't I predict in the coming days, is it going to be uptrend or is it going to be a low trend? I can easily forecast. It's only forecasting, friends, not the exact figure. I only predict. That is what I call it to be predictive analytics. Understanding the past, analyzing the current, throwing light into the future is what we call it to be the predictive analytics. Predictive. We are just predicting. Maybe the results, the actual results may go slightly here and there, but not too abnormal. Too abnormal. That is what I call it to be predictive analytics. So with my domain knowledge as a researcher on the literature, with my domain knowledge, you and me may not be able to finish this research. We don't have that much skill. But who is actually involved at the grassroots level, they definitely can analyze with their domain expertise. They also can predict in future the impact of the social circumstances in the writings of the authors may be increased or may be decreased. You come to know that one only by analyzing all the last 200, 300 years of data. And for this sake, the only alternative is your HDFS and MapReduce, because you're essentially working with huge data, a lot of files from different authors, and all this data needs to be processed. It's not viable to get processed in a linear fashion like how we used to do with your traditional programming model. This makes sense now, Ram? This makes sense?
Yeah, a little bit.
Now, where is that you have the ambiguity in understanding this use case? We have executed the word count program, right? Against the file called Mary, and we got this one. Now, the same word count program, we are going to run it in the directory. Which directory? 1700 to 1750 directory. We also get the word count again. Let it be a directory or a file or a glob. What all been matched, all been processed. So when I run this same word count program against the data present inside the directory 1700 to 1750, I get the word count again. Now that word count, what I am asking you to do is, using my BI infrastructure, I have the chance to eliminate the regular words like is, was, to, and, like these kind of words I eliminate. And the rest of the words that I see, they are sensible words. Those words one side of the coin, and the other side of the coin, the social circumstances prevailing that time. And both I compare the social circumstances and the as part of the writings of the authors who lived between 1700 and 1750. How many words mapped with the social circumstances are being repeated here? Then I understand and estimate the social circumstances prevailing that time has influenced the authors to keep those conditions in the writings to an extent of 20% or 25% like that. So in the coming days, by analyzing my past and current data, I can put myself, I can predict this may happen, or there is a possibility to happen this one. So that kind of prediction can be done. How? In the coming days also, the impact of the social circumstances will be there on the others or will not be there. If at all, if it is there, to what extent it is going to be there, we get the answers to all those questions. And that's what the research on the literature, what I mentioned here. Or tell me in what way this big data is connected to a research scholar who is doing the research on the writings, and especially in the English literature. How these two are connected. I think you're getting the point, how big data can be used or leveraged. If at all, if it is needed, how it can be leveraged. You might have noticed here. Yeah. Is it not clear still? The same word count program. No much different. Instead of you running it against one Mary file, you're going to run against multiple files that are been. And if you say that where I get the data, definitely the data is accessible to the researcher who is doing that research. The data may not be accessible to you or to me, but who is actually doing the research, he may have access to the data and he can use comfortably in this and predict. In the coming days, the impact of these words, the prevailing circumstances in the writings will be to this extent. I can predict a lot of things. I can start analyzing the maturity levels of the authors and their thinking style. A lot of things can be analyzed so that I can expect these kind of writings from the authors in the future, near future. So that all prediction can be done by the research scholar who is doing the research on the literature, especially in English. He is able to give that. You see a lot of times, right? Research, the result of the research is this. After thoroughly studying for 20 years, 20 man years, this is what the outcome. So we get these kind of intimations time to time. How? After doing the research only, after mining the data only, we were able to get those things. Like how in this case, an English literature researcher, how he was able to predict in the coming days what is the impact of your social circumstances on the others. Same like even by analyzing the data, they were able to come to those conclusions which are being shared with you time to time. Is that clear now?
Yeah, Srinivas, it's clear. Just a small thing. So your output file you're mapping to one of the BI adapter there.
Yeah.
So you're going to show in the graphically your visualization. And so whatever the data you available, you're showing in the graph. So how we are going to do that predictive analytics? Like also, like you're using something.
That is what the next. I think you remember the diagram which I have shown you. In that, you might have noticed you have at the very lowest level you have storage. At the very lowest level we have storage, and on the top you have processing. You remember the diagram which I have shown you, and on the top you have something called access, and on the top you have something called management. This all is your Hadoop stack. This all is your Hadoop stack. What is there as part of the storage? HDFS. You also can have HBase. You also can have S3. You also can have MapR. All these can be a part of your storage. Processing, you can have MapReduce. And access, you can have Pig, Hive, Scoop and all. Management, we have Zookeeper and all that stuff. So this all is a part of your Hadoop ecosystem. On the top of this one, you have something called data analytics. Once our part is over, why we are doing all this data processing, why we got this one, why we got this output, How this output is going to be used by the analyst, we don't know. Our job as a Hadoop developer is only to produce the data to this extent, that's it. The rest part is going to be taken care by the analyst team. That is not a part of your Hadoop. That is, of course, a part of the big data only, but not a part of the developer role. Developer role is only to this extent, and this is what we call it to be big data developer, and this is called analyst, big data analyst. I think you got the point, Ram, what I'm sharing here.
Yeah, it's Prasad there.
Prasad, you got the understanding?
Yeah, I got.
Yeah, what I'm
Yeah,
trying
I
to
got
share
that.
here, because that is not, maybe out of your interest, you want to do something, that is fine. But when it comes to the actuals, that is not the responsibility of the developer. Developer only develops to this extent, that's it. My role is over. How this data is going to be used by the next level of people, that all depends.
For example, I'm going to connect a Tableau for this output, or like any data like HBase or S3.
Yes.
So I'm going to connect to the database like HBase and S3, and based on the database, like I can show you the graphs and all.
Yeah. So not only that one. See, not only that one. To be honest with you, as a developer, you can do your basic analytics at your Hadoop level itself. Ad hoc analysis can be done at your let me show you that. Ad hoc analysis can be done at the Hadoop level itself. But I'm talking about the true analytics. I'm talking about the true analytics that we actually, the true analytics that now we perform based on the output produced from our end. So we are producing this one, right? Whatever we are producing now. Based on this, you want to do the analytics. I give you one other example here. Last 50 years or maybe last 100 years, weather data, if I analyze, weather data, because these data sets are there. I'm going to show you practically, friends. Don't worry for this. So last 50 or 100 years weather data, if I analyze, I come to know the maximum temperature recorded in the year 1900. The max temperature recorded. This is the year and this is the max temperature recorded. Maybe 38 degrees centigrade issue. In 1901, it is 39 degrees centigrade. In 1902, it is 36 degrees centigrade. Like this, if I process all my weather data available in the last 100 years or 50 years, whatever the time frame, as a weather scientist, not you and me, as a weather scientist, I can draw a graph. One is the year and the other one is the temperature. I'll be able to get something like this. Now looking into this pattern, next 4 years, 2017, 18, 19, 20 and 21, can't I predict what could be the maximum temperatures globally? With my domain expertise, it's only a prediction here, friends. That is why we are calling this as predictive analytics. Maybe we may go slightly here and there, but not totally upside down. We may go slightly here and there. We correct again. why, what is the result, what is the actual result and why there is a deviation. We analyze it again, that's a different story. But if you see closely this one, as a weather scientist, this graph is meaningful only to the domain expert, not to you and me. This graph is meaningful only to them because they have vast domain knowledge and expertise, and looking at this data they can easily predict, oh, last 4 or 5 times this is what the trend, and this time also the trend is going to be something like this. So I come to know all those things only by processing the data. And how I process the data, what I have shown you now. That is how I process the data. See, certain level of predictive analytics can be done here itself. We can do that one as part of your environment itself. Say for example here, I say select star from customers. I run this one. I get some output, and here I go to the chart. I can see in the x-axis what I want to keep, and in the y-axis what I want to keep. That if I am able to do it, I can get whatever. Getting the point here? Prasad?
Yeah, yeah, sure, I got that. But this is internal to Hadoop developer. If you want to publish to the some business people,
Yeah.
you show the graph, real-time
No,
one.
we cannot do that publishing and all from within your Hadoop ecosystem. We only,
Yeah, that's what I'm saying.
yeah, we only give the access to this path. We only give the access to this path so that using their own, we only give the access to this path. What is the path here? Sorry, /tmp /sandbox. Only this path we are going to give access to the tools used by the analysts using Tableau, Datamir, Pentaho,
Yeah,
whatever the BI. I connect because these days every BI tool has got a Hadoop connector. Every BI tool. So
yes.
using those connectors, I can directly connect to these output directories, and from here I fetch the data and I analyze that one. As an analyst, okay, maybe you want to have some basic analytics happen at your level. That is always there here, what I've shown you just now. That is always possible, but this is not, this is only the ad hoc analysis that you do in terms of maybe weblogs. You take select star from weblogs. I execute this one, and I need to understand basically what columns we have and all that stuff. And you see that here, and what is the city wise, maybe I take the protocol and I take the we don't have much data in this context.
So we can take the date,
Yeah,
last, last column.
your date, and maybe Launch date. What other could be taken? Major protocol, record, refer. I think
You
we
can go
need to
with
have
the agent.
understanding of what this. Let me see what columns we have there and what is the type of each column. Then only it makes sense for us to analyze the data, right? Not just bluntly doing it. We need to have the understanding what columns we have here.
Yeah, I got that. Yeah.
So based on that only, describe web underscore logs. Okay. So I come to know that these are string type, then I'll not be able to get much analytics keeping x-axis, y-axis. Date time, okay, fine. All these are string type. That is the reason why we are not getting much. So you can specify the columns. What are the columns that you want to analyze here? But this is entry level. I don't claim that this has got fantastic analytics capabilities. But thing is, your data can now be given access to the BI tools, and they can access this data and do their own analytics. They can do their own analytics. So as a developer, our job is only to understand. As a developer, that is where I'm coming now. As a developer, our job is only to understand the data set in detail, and once you understand this data set, I also need to understand what is the requirement. What is the requirement? Requirement one side and the data set the other side, and based on this one we are going to write the pseudocode, and this pseudocode I translate or I design the algorithm, and based on the pseudocode I actually translate that into your MapReduce job implementation. That is important to us. In the MapReduce job implementation, once I do this one, convert this pseudocode into the MapReduce implementation, I make that to run against this data set and produce the expected outcome. And this expected outcome is actually going to be consumed by the next level of stakeholders called analyst. And you as a developer, big data developer, your job is only to understand that. And other side we have one more role called Hadoop admin, whose role is to manage the resources and all that stuff in the cluster, adding new nodes, making the upgrades to happen, performance tuning. All these things have been taken care by the Hadoop admin. As a developer, you only going to do these kind of things. So that is all going to be consumed by the analyst team, who is going to sit next to us. They actually propose and give the requirements to you. Based on that only, you are going to process the data and share it with them. What they do with that is their headache. As a developer, you need to clearly understand what is the data set and what is the data set and what is the requirement. Only then you will be able to write something as part of your MapReduce implementation. Make sense? Look at this one very closely, friends, for a minute or two. Please go through this one. This is what I call it to be your MapReduce job life cycle. MapReduce job life cycle. Let you run your MapReduce job through your peak. Let you run your MapReduce job through your Hive, any form. Ultimately, wherever MapReduce is there, this is what the life cycle of that MapReduce job. Please watch this one carefully. We'll have a detailed discussion on it now. We'll have a detailed discussion on it now. And this diagram must be engraved in your mind. And I'm going to share you the document on MapReduce in the blog. As part of that, this diagram and the other diagram, both are there. I'll be showing you that one. We'll have a detailed discussion. Please look at this one and try to understand. There is node 1 and node 2. You need to understand here. Node 1 and node 2. Two nodes are there here. And we have we don't see something called block here. We see something called split. What difference exists between block and split? We see it practically now.
Srinivas, Srinivas, are you there?
Yeah, friends. Hope you have seen this diagram very closely. Now let me take you to MapReduce example, or the word count example. I asked you to go through this one. I don't know whether you have gone through that or not. As part of this, in the driver code, I explained you very in detail. Any MapReduce job you take, you have three major parts. One is the driver code, which you write inside your main method. Okay, this is the driver code which you write inside the main method. And then you have a mapper class. This is a class basically. And then you also has got reducer class, right? You have a mapper class and you have a reducer class and you have a main method. This is basically an inner class. All these been packed into one thing called your job. This is your MapReduce job. Because this mapper logic is required only in the context of this job, not outside this one. That is the reason why we made this as a static class and static inner class, which may not be useful to you in other contexts. That is confined only to this job. So out of those three parts, you see closely, the driver code, job.set, mapper class, combiner class, reducer class, all you see here. And job, file input format dot add input path, whatever the path that we specify, input path and the output path. So along with these, of course, this being a plain text file, you are not seeing that one here. But if you look closely, the MapReduce API, you have something called or.apache.hadoop.mapreduce. In that you go and see job. In the job section, job.set, you have the set methods available. Set one moment. See here, friends. Job.set input format class. This is the starting point for the execution of any MapReduce job. Set input format class. You need to specify the input format. So for that sake, you see here or.apache.hadoop.mapreduce.input format, which you are seeing here, input format. Input format describes the input specification for a MapReduce job. The MapReduce framework relies on the input format of the job to validate the input specification of the job, split up the input file or files into logical input splits, provide the record reader implementation to be used to glean the input records. You come back to this diagram, friends, and see what is being represented here. Based on the input format only, the splits are decided. Each split is processed by one mapper with the help of the record reader. With the help of the record reader. The record reader is going to read the records and give a key value pair to the map function. That is the reason why you see closely here your map function. The mapper class map function, if you take, it takes a key value. You see this here? Key and value. Of course, the third argument called context object. Even you take your reducer, reduce method also going to take key and value, and the third object is a context. Third argument is the context. Even you take your partitioner, there also your get partition method takes key and value and the number of partitions. So across your entire MapReduce framework, you always come across the concept of key value pairs. A record is always split in the form of key value. You see now here, friends, you understand and appreciate. You have the data set. So I use the term called data set, but data set is nothing but a file, nothing more than that. Data set is nothing but a file. Now given a data set to you, now this data set has got records. Of course, data set will have blocks, and inside that blocks we will have, or we call split also. In the HDFS context, we call it as a block. In the MapRed context, we call it as a split. So block is exactly 128 MB, neither 1 bit less or more. It is exactly 128 MB in size. Whereas a splitter, the problem with the splitter, the difference between the block and the split is, why we require a split when we come to the MapReduce is for the reason, have a look at this one, friends, you understand. As I told you just before now, as part of this data set, what we will be having? Records. From records only we get key value. From record only we get key value. Record nothing but in terms of text files. In terms of text files, records are nothing but lines. In terms of text files, records are nothing but lines. And lines are divided to key value pairs. Lines put together data set, and data set can be viewed as a block or in the form of a block or a split in two different contexts. In the HDFS context, we call it as a block. In the MapRed context, we call it as a split. The reason behind it is, see here, block boundary is exactly 128 MB. That's it. It doesn't care whether the record got split into two blocks or not. It doesn't care. Now the problem is, according to the diagram that I've shown you here, each split is processed by one record reader. Now, when the record gets split into two blocks, whether the first mapper need to produce the, process the record, taking the leftover part from the second block, or the second mapper needs to process the data by taking the first part of the record from the previous block. The ambiguity arises. That is why situation arises to me to divide my data set into one more type called split. A split always carries whole number of records. A block always carries whole number of bytes. This, if you are able to understand, you can definitely appreciate why we require two mechanisms. Because there are chances where when you are cutting the data into blocks, not intentionally we do this one, There are occasions where a record may split into two blocks. Part of the record in the first block, remaining part in the second block. That possibility arises maybe one time or many times in terms of a data set. Then the ambiguity arises. To resolve these kind of ambiguities only, we have brought one more thing into picture called split. We have brought one more thing into picture called split. See this split here? Split contains whole number of records. The first split has got 5 records. The second split has got 1, 2, 3, 4 records. The third split has got only 2 records. So the intention of showing you this diagram, don't ever think a split must contain a similar number of records. No. Split always contains whole number of records whose size is very close to the block. Very close to the block. I think you got the point here, friends. Why my HDFS block concept need to be changed to MapRed split is to make your processing happen efficiently. Hope you got the point here, friends. Input splits. Now come back to this diagram and see. Based on the input format, if it is your text input format, that is what input format indicates here. See, you have number of input formats, out of which you have file input format. Under file input format, we have text input format. If it is the text input format, this is the input format for plain text files. Files are broken into lines. Either line feed or carriage return is used to signal the end of the line. Keys are the position in the file and the values are the lines of the text. Now I think you understand clearly, friends. In the map function, whatever we are getting here in the map function, this is not important to us. Text is nothing but the line, entire record. That is the reason why value we are converting into string and into lowercase, that we are converting into tokens, and each token, now you look at this one, whatever the file that we have kept here, data sets, Mary, if you see, now this is called a line. Now this is going to be a record where the key is going to be the starting, what is there before Mary. I think you know very well, every block will have a beginning and ending. Every split will have a beginning and ending. That beginning is what we call to be my offset address. That is not the absolute address. That is address for this block or split only. Now that is a starting point. I take that as 0. From there I start counting. 0, 1, 2, 3, 4, 5, 6, like that till the end. That 0 is the key and Mary had a little lamb is the value. 0 is the key, Mary had a little lamb is the value. For the first thing, 0 is the key and Mary had a little lamb. This is going to be my value. This is going to be my key. Now this value is converted by me into string, that string into tokens, and each token, if you see, Mary 1, had 1, a 1. Like this, I am going to produce the output from the mapper function. So till when that is going to be done? Till there are records present in the split, the mapper is going to produce the output. Where that output is being stored? That output is being stored in a temporary mode in your local file system. Local file system, friends. Because this is node 1. One split is being processed by one instance of mapper. Another split by another mapper. Another split by another mapper. If more splits are there, more mappers may be executing. Within the node 1, 3 instances of mapper processing your data across node 1 and node 2, you have the data getting processed like this. That is what we are technically calling it as parallelism inside parallelism, called as massive parallelism, which is the backbone for your entire MapReduce job execution. And this is what the record, that is 0 is the key and the entire line is the value. And next, when this situation arises only in the context of your, what is that, text input format. Like text input format, we have other input formats like sequence file input format, key value text input format, combined file input format, fixed length input format, n-line input format. All these are the input formats for your, the subclasses for your file input format. You have other classes even, DB input format, composite input format, and composable input format. So input format is a base for your MapReduce job execution. Is a base for your MapReduce job execution. You need to understand that one, friends. From that only we got the split record reader read the records and give to the map function in the form of key value. Now from this particular node, Mary 1, we might have got from 3 different splits after processing is being done. I got Mary 1 from first block, Mary 1 from the first block, and Mary 1 3 times from the third block, third split. Instead of me passing all these 5 as Mary 1 across the network, I do the local aggregation by saying Mary 5. So that my data transportation is going to be more cheaper, and that's going to improve the efficiency of your job execution. So that is all been done by your local aggregation, is going to be done by your combiner. And what your partitioner is doing, your partitioner is deciding which key value pair should go to which reducer is decided by the partitioner. But who actually transports the data, physically, that is by your shuffle. After shuffling is been done, before the data is given, the output is given, you have the sort phase. After sorting is done, that is going to be given to the reducer. Reducer reduces the key value pairs and finally give the outcome. That is the reason why you are seeing here, friends, very clearly. You are seeing the output here. What is that? You see the file, the output file, what you got, /tmp/sandbox/Mary_out. This file you see, you have your key value pairs in the ordered form only. See here, because these being the capital, you got like that, A, about, all these things you see, they are in the alphabetical order. Because after shuffling is been done, sorting is going to be done before the data is shared with your reducer to finally reduce the data, which is considered to be the output of your MapReduce job. This is the entire life cycle of the MapReduce job. So you need to understand this one closely, friends. Any question? You have any questions, please feel free to ask, friends. I want you to be very, very clear with this one. No queries before I move on to the next thing. Then only it makes sense. Otherwise, it will be very tough for you to follow the next sessions.
Srinivas, actually, what I understood is the MapReduce job is like processing the data into Hadoop cluster, right?
Yeah, process the data. File, yes.
But in this example, I don't think we are processing the data. We just getting the result of the input file.
Now, how you get the result of the input file without processing? No,
so you want to say you
this is a Mary file. Now this Mary file, this is a Mary file. From this Mary file, we got the output, what I've shown you. How you got that one? without processing is being done? If no processing is being done, who is giving the output? Mary 5 had one, little one, like that. Who is giving that output?
So that is the logic what we written in the MapReduce job,
Exactly.
right?
Exactly.
But this is not processing to the data nodes, right?
Processing in the data nodes only. This has been processed in the data nodes only. Otherwise, where it has been processed, but only thing is, here we have only one data node. No, what exactly is your query? Tell me, then I'll explain it.
Okay, so we have our input file, which is a Mary file.
Yes.
Okay, so from there we are going to process this Mary file into our Hadoop cluster.
No, with
Like
our
it, data
MapReduce
nodes.
job, with our MapReduce job using Hadoop cluster. Yeah. Go ahead.
Yeah, so MapReduce job is what MapReduce job is doing. Just picking the like the input file and doing some logic and
My MapReduce job is reading the data from the file line by
yeah,
line
reading the file.
in the form of
Yeah,
p-value pair. That
yeah,
value is being split into words and words are being aggregated. All that is done using my MapReduce job only.
yes, I got that.
Right? So that
Yeah,
itself is called processing. What do you mean by data processing? You have the data set, you give the data set as an input. What is input to my program? Mary file. What is the output from my program file? I mean from my job? Word and its occurrence is output. So without processing this data, how come you are able to get that output? You are getting that output, whatever I have shown you, is all because of the processing done by your MapReduce job. Is that right or not?
yeah. This file is in HDFS. So in this
Exactly.
HDFS,
Yeah.
and the Mary file is in HDFS. In this file, HDFS, it is split into the different data nodes, blocks, different blocks.
Yes. Yes. Yes.
So your MapReduce job is reading the file from the blocks and splitting into that based on the records
Yes.
and based on the values, and it's giving the output.
Exactly.
Okay.
It is being
So
stored on the HDFS again. The output is being stored
yeah,
on the HDFS again. Slash user slash lib slash Hadoop, and here Hadoop examples.zar word count slash tmp slash sandbox slash Mary slash tmp slash sandbox slash Mary underscore out. Now see what is happening here. Now closely observe. I am running it once again for your sake only. What is happening here?
yeah.
Now,
So it is,
yes, job is been submitted to the job tracker. That is been
yeah,
accepted. Map phase is been executed. Where the map phase? See, in a pseudo cluster, all happens on the same node. That you need to understand. Maybe on a production cluster, we can have mapper spread across nodes, like what I've shown in the diagram. Now done. Now I go here and I take my /tmp oh my god, still love Mary and all, somewhere I left. So you got that output now. Now I'm asking you, how come you got that output? How come you got that output? This output you got, how come you got that?
Processing the MapReduce job, right? So yeah.
Right, your
the
MapReduce
mapper.
job is processing that one and giving you that outcome, right?
Yeah.
So where you are, how you are supplying that to your job tracker? By packing your MapReduce job in the form of a jar file and submitting it to the job tracker.
Yeah.
Right?
Yeah, understood. And this output file again is storing it to the HDFS only.
Absolutely.
Kind of inserting the file into the HDFS.
Absolutely. Because that is what I've given you in the beginning. You remember? So whatever I specify here, this is your local file system. Whereas this is your HDFS path and your output also is your HDFS path. This one also. Clear?
Yeah.
Now how this is getting started basically? How this is getting started basically?
Which one? MapReduce?
Yeah. Based on the input format.
Input file. Yeah, input file. So when the input file arrives in HDFS, how the distribution will happen? Like it's good different blocks and all that we can't see, right? But it's automatically whenever the file reaches to the HDFS. So now we have a small file, Mary file. So like we have a big file, 10 dB file. Then it's going to be automatically split into clusters, different nodes.
Yeah.
Also, adding to that Prasad's question, like let's say this is a,
tell me once again.
yeah, adding to what Prasad was asking, like let's say the same this movie file is in like 1 petabyte or something.
No,
So
in this case,
you mean like
the problem is, this entire thing will fit in one block only. But if it is a big file, then it is going to be into multiple blocks, right? Here, what is the size of the cluster? I mean, what is the size of the block in this cluster? Is 128 MB. So if the file size is a 2 gig or something like, then only we get blocks. Then only we see those things happen. But in this case, your entire data sits inside one block only. You got the point?
Yeah, actually, so in case of 2 gigabyte, so we have a different blocks.
Yes.
So how will identify that this is in different blocks? How are you going to write a MapReduce job, like the mapper logic?
No, that is the reason why I said we don't write. We only submit the job to the job tracker. See here, that is why I explained you this entire scenario.
Oh, okay. In every data node we
The
have a
job
task
tracker
tracker.
will internally communicate with the name node asking the client asked me to process this data set, I mean this file. The job tracker is going to ask the name node, please tell me where this file is located, how many blocks are there for this file, where those blocks are located. All those details will be returned by the name node to the job tracker. And what job tracker will do? The same jar file is being pushed to all those nodes.
Yeah, okay, got you.
So that
Yeah,
is
that
what
makes
I'm
sense.
trying to explain you here. That is what I'm trying to explain you with this diagram. Let me show you the diagram. Yes. See here, the same jar file is being submitted to all the nodes where the blocks are present for the given data set. See, your cluster may have 100 nodes. It will not send to all 100 nodes. It will send to only those nodes where the blocks for the given input file are located. I mean, for the given data set, there are 100 blocks assume. Those 100 blocks are present in node 1, node 3, node 4, node 9 and node 11 assume. Then the jar file is sent only to these nodes, not to every node in the cluster. You got the point?
Yeah, so that will be decided by the name node. So, okay.
Not decided. We are submitting the job to the job tracker. Job tracker will request the name node. Client asked me to process this data set. Tell me where the data set blocks are located. Name node will respond. Based on that response, the job tracker will decide to which nodes this needs to be sent.
Yeah,
And on
yeah,
those
clear.
nodes, the task trackers are readily available. Those will receive the jar file and run them locally. Each block is processed by one task. Each block is processed by one task. You can see here. Under task tracker, if you have multiple blocks, then the blocks are going to be processed by, each task is processed by one task under the control of task tracker. Make sense?
Yeah, clear. Yeah.
Now you can see that here. This is a more detailed diagram. Now this makes more sense. See, mapper 1, instead of saying 6171 6171 like this, what the combiner will do is 6371, so that the amount of data that needs to be transferred in the network will be minimized. You got the understanding what your output is, how the output is getting processed? I mean, how your input file is being processed and finally being the output given?
Yeah, clear. Sure.
And you
So the
understood
mapper
what are the different phases involved in your MapReduce job and the role of each phase?
yeah, yeah. So the mapper part is internal to the node, and after that mapper like a partition and shuffle is between the different nodes. Node 1, node 2, node 3.
Yeah, you are absolutely right. So that necessarily need not be on the same node. They can be on different nodes. See,
Yep.
but every node will have a partitioner. Every node will have a combiner. For the entire nodes, there will be shuffle and sort process only one. And reducers could be number of reducers. I'm going to send this diagram to you. I'm going to send this diagram to you. Please go through this one. This one I will send, this one I will send, this one, all three I will send. Along with that, I will also send the MapReduce notes. I think you remember in the last session, I requested you to go through the API. The reason behind that is this one only. Until and unless we go through this one, we will not be able to understand how your processing is happening. So the entire activity is getting initiated. The entire activity is getting initiated from one single thing that is called your input format, which is the most crucial thing. I want you to go through this input format at least 10 times. Repeatedly go through this input format 10 times, 20 times, nothing wrong. So that we'll be able to understand how these can be. Now in the coming session, what I do is I take other data sets and other MapReduce jobs so that we can understand how these can be achieved. Okay. The word count program, a very interesting use case this is. The reason to take this kind of use case, friends, the reason to take this kind of use case to make you to understand big data is not only meant for your IT, your sensor data and all. Big data can also be used in this kind of context also. To make you to understand that one only, I have taken up this example. You will not find this kind of use case with Cloudera or anyone because they never look at this this dimension. But this is to make you to understand that yes, is possible. So please go through all the things, whatever I discussed in the today's session. Still you have questions, never mind friends. I have enough patience to explain you the entire story once again. Provided, you know, you do your homework and you have questions, I don't mind. You want me to repeat the entire session, what we did today, tomorrow? I mean, in the next session, no problem. But you ask me to repeat this one after finishing Hive or Scoop kind of thing, then it is definitely going to pain me. And that will be of no use to you. That is the reason why I'm asking you to go through this one thoroughly before we meet in the next session so that all your questions can be cleared on the MapReduce part so that we can work more closely on this.
Yeah, this is clear, Srinivas. So one small request, Srinivas, I don't know, so others agree with me. So can you please mention in your conversation, like which will be the automatically internal to the Hadoop, and which is the developer has to do something, because it's confusing. Like so there are a lot of stuff done by Hadoop itself, like automatically in the background. So that's a confusing actually for me.
Yeah, that will be there. That will be there initially because see, we are coming from a background where you know, everything is done by us, executed by us, taken care by us, right? You develop a program, you run that, and you know, you do all those things. But here we only develop the code and leave it to the cluster. It will take care of running everything.
Yeah, that's clear. Yeah, so that's the thing is confusing.
Srinivas, I have a question. Ram.
Yeah, please.
What do you think are the some of the MapReduce business cases that you came across, like this word count that you might have to, you know, in your applications that you have to write, or
To be honest, in the real time, in the production environment, MapReduce directly is being least used. I mean, you take any typical scenario, MapReduce is being least used. Directly, I'm saying. So the most widely used in the industry all the times is Hive only. And then comes is your Pig. Then comes is your Scoop. And then comes is your Uzi. And of course, Flume and Kafka is being set up and being used by the people consistently to push the data into your Hadoop. So this is a different thing. This is being taken care by the admin, where data keeps coming into your Hadoop ecosystem, I mean HDFS constantly. We process it using Hive or Pig, and the data present in your RDBMS that we bring into HDFS using Scoop. And Uzi is a scheduler, workflow scheduler or workflow execution engine with which we are going to make all these things. So MapReduce directly is least used. MapReduce directly is being least used. I think you got my point. Even if it is being used, because MapReduce requires extensive skill set to use Java APIs. People having 10, 12, 13, 14 years experience in SQL and various domains, we cannot expect them to learn Java all of a sudden and start writing matured or high-end MapReduce jobs. Because of that only, Hive, Pig and all came into picture. So MapReduce is being least used. Even if it is being used, not being directly in the form of MapReduce, but indirectly through your Pig and Hive, it is being used. Right?
I got it. So you mean like Hive, Pig, like they have some inbuilt jobs, like commonly used jobs, like which can be extended, and without writing those, we can directly use them. Is that what you say?
No, come out again.
I was asking, like Hive and Pig, they have some inbuilt jobs, which MapReduce jobs, which you can directly execute.
No. Every maybe you come to know more clearly rather than giving me a vague idea. When you write a Pig script and you run that one, it actually converts into a MapReduce job and run it. There is a compiler which converts your Pig script into MapReduce job and run it. So we need not do that one. There is a compiler available with the Pig environment that takes care of converting your Pig script into MapReduce job. So that has been taken care. So instead of we writing a MapReduce job on our own, we can get it done through your Pig or something of that sort. I tell you here, then you will be able to understand. We have done the word count example, right? We have done the word count example now in MapReduce.
Yeah.
The same word count can be done in Pig using these 4 lines. But when you run this 4 lines, it actually produces the same word count what you are seeing here. It produces that. And when it comes to the physical execution, this only will run, not your 4 lines. So your MapReduce job is wrapped inside this wrapper. But actually speaking, that MapReduce job only will work in the background, even when you run these 4 lines of code. You got my point?
Yeah, I got it. It's clear now.
So that is the reason why most cases, I don't say and I don't discourage you, but understand one thing here. Without understanding this one, you never can understand how these 4 lines of code getting executed in the background to produce word count output. That is the reason why we need to understand, learn, digest MapReduce part. So we see good examples as part of our sessions, then it makes more sense. In the next session,
Sure.
we see more examples
Yeah.
of MapReduce. Then you'll get understanding of this, how you can. But make sure that you need to have some basics of Java to understand those things, and without which you will be definitely feeling it as a Greek and Latin. Yeah, go ahead.
So you said, Srinu, that we will be going with the Eclipse setup to write our WordCon program from scratch, right? That's what is you're expecting in the next class.
Exactly, exactly. We have the Eclipse already available in the environment. That is what you're seeing here. Using that, we will be writing a MapReduce job. I'll be explaining you. That I'll take care. But understanding the code, the MapReduce job code, that you should take care, because that is all the Java basics. That is the reason why I asked you and I informed working with the API in the last session itself, so that you can constantly go through that API, where you will not be facing the challenge. How come I am using extends mapper and start using map function, extends reducer and start using the reduce function? That is all from the API.
Got it.
All right. So good that we have a very extensive session today, because I cannot cut this into parts. That's the reason why I extended this one. I appreciate your patience. Please go through this recording once again. It's very, very important for our future sessions. If you have any question, please let me know. I'll try to explain you in the next session. No worries.
Sure, Srinu, you said like you want to share some these pages or something.
Yeah,
I'll
I'll make that to be available to you along with the
blog.
recording that is available in your blog, so that you can access them.
Sure, that'll be good. Sure.
Yeah.